my channel. So in this video there are two goals. The first goal is to solve this problem, and the second goal is to try to see how you should behave in a real interview. So before we start the real content for this video, I would really appreciate that if you can help subscribe this channel, because it can help me to grow, so thanks in advance. So let's take a look at the question. So remember, in the real coding interview, always try to understand the question first. Don't jump into the coding part too quickly. And also, if there's anything unclear, don't be shy to ask questions. And also, at the same time, think about some edge cases you need to deal with especially. So let's take a look at the question. So given n non-negative integers representing the histogram's bar heights, with the width of each bar is 1. So find the area of the largest rectangle in a histogram. So for this one, let's say the maximum rectangle we could use the bar to get is 10. So it's like essentially this area, which is represented by the orange slashes. So similarly, for example 2, we have the maximum area as 4. Alright, so let's see the constraints. It said that the input array is not going to be empty, so it has a length between 1 to 100k, and also the height could be anywhere between 0 to 10k. Alright, so it seems like there isn't too much of the room for us to think about edge case, so let's start to think about solution. So the first solution that comes to my mind is to use to try to extend, like let's say for each of the bar we try to extend into two directions, the left direction, the right direction. So for example, for this 5, we could try to extend to the left direction, which there's no room for us to extend, but for the right direction we can extend to the right by 1. And then we have the maximum area as 10 currently, so that one, like for this one, it is going to be an n-squared solution, because we try each point and we extend into two directions, which is going to be all of n for each of the point potentially, and then we have n points to enumerate, so in total it's going to be n-squared. So that one is not the most optimal solution. So actually we could do better than that. So one solution which is quite fancy is we could use we could maintain a ascending stack. So what is ascending stack? So what I mean by ascending stack is everything within the stack has a height from the smallest to the largest, like it is in a increasing order. So the rule here is, if the current height, so still we are going to do one pass through the array, but at the same time we need to maintain something called ascending stack. So we have, if we have the current height to be larger than the stacked top element, then we are going to push to stack. Otherwise, if the current height is smaller or equal, then to maintain a ascending stack, to make sure that the height in the stack is in ascending order, what we need to do is we will need to keep popping from the stack until it is empty, or until the current height is larger than the stack.top, and then we push. So in this way we maintain a stack, like increasing stack or ascending stack. But at the same time, we also need to compute the max area of rectangle. So for example, let's say we encounter the 2. So because 2 is smaller than 6, to maintain a ascending stack, what we need to do is we keep popping the 6 and 5 from the stack. So at the same time we need to compute, so we have the height of the rectangle, but we still need to compute the width of the rectangle to make sure that we can get the area. So once we have the height, how do we compute the width? So the width essentially it is the index of this two minus the index of the previous one of this one. So let's say if I pop the 6 from it, and the top element actually here is indexed as this, is pointing to this 5, and then the width is going to be the index of 2 minus the index of the 5, and then minus 1. So that's pretty much how we compute the area of the rectangle. So this one is going to be an ON solution, so it's a linear solution because we just need to touch each of the animals twice. So having said that, let's do some coding work. So for coding, we care about the speed, the correctness, and the readability. So at the very beginning, we have the stack, which is integer. So stack is going to be used to store the index of each of the bar. So we are not going to store the height of the bar. That is because we need to compute the width of the rectangle. So we need to compute the width of the rectangle, so we need to store the index instead of the height of the each bar. So we have the stack, and also at the very beginning we have, let's say we have the max area defined as 0, and then we do one pass. So we do one pass through the input array. So like the first condition, if the stack is empty, or if the current height is if it is larger than the top element, so which is heights this is stack.peak, then we are going to push the thing into the stack. So we are going to say, okay, stack.push the I into it. Otherwise, we need to keep popping from the stack. So well, not stack dot empty, and height I is smaller or equal to heights dot stack dot peak. So well, that's true, we are going to have, let's say the top index is equal to stack dot pop, and then we are going to have the current height. Let's say the current height is going to be this should be height. So it should be height dot top. This is the height, but we still need to compute the width. So what is the width here? So if the stack dot is empty, so if the stack is empty, then it means that everything coming before this index has a height to be actually it is going to be, so let's say for this one, so let's say I give you an example. Let's say we have 5, 5, 5, 5, and 4, and let's say we have 3. So when we try to pop, when we encounter a 3, then we are going to encounter the 4. So anything that comes before the 4, if this one is in the index, then it means everything that is, let's say we have a 2 here, so everything between this one and this one has a higher height than this. Otherwise, it should be within the stack. So that's yeah. So that will be a example I give you here. So I would say if the stack is empty, then it means it's just the I here. Otherwise, if it is not empty, it is I minus the stack dot top, then minus the 1, or it's just the peak. Alright, so we have the, and then we need to compute the max area as mass dot max as max area, and then current height times the current width. And otherwise, we should be good. But at the end, there is still some possibility that the stack is not empty. So for example, if the everything like the bar is like with 1 2 3 4 5 keeps increasing, so we are never going to jump into the else branch. So we are going to have a similar else branch here outside of this for loop. So we are going to say okay, so this is stack empty. We are going to have the top thing. You're just going to keep it here. So the only difference is So the only difference here. So the only difference here is how we compute the height. How we compute the width. So how to compute the width? If it's empty, then it's pretty much just the height dot length. Otherwise, it is heights dot length minus the stack peak minus 1. So that's pretty much it. And finally, we just return max area. So let's run through this piece of code. Okay, so there's some typo here. So it's run. So let's see why. So we must have done something wrong here. So we have the stack here, and the max area, and we have the reiter through this, and the stack. If the stack is empty, or if the current height is taller than the top element, then we are going to push. Okay, so I think I forgot to push it here. That's essentially why. So I forgot to push the I finally. So after we pop everything, we should also finally push the thing into the stack. So okay, so that's pretty much about the question. So don't forget to do some testing. If you don't have a runnable platform, please just set up the test case and run through it manually. So that's it for this coding question. If you have any question about the solution or about whatever, so feel free to leave some comments below. If you like this video, please help us support this channel. I'll see you next time. Thanks for watching.